This video is about the structure and contents of my book, Converged Communications, Evolution from Telephony to 5G Mobile Internet. The book introduces several communications technologies, such as fixed telephone systems, data communication systems, mobile systems, and IP multimedia systems. The description of a single technology in the book covers these kinds of aspects: the services provided by the technology, the communication network and protocol architectures, the individual network elements and protocols within the architecture, system interactions between the network elements using the communication protocols, network access interface details. Let's take the GSM mobile system as an example of this approach. All the diagrams shown in the video are taken from the book. First of all, the GSM network supports voice calls and various supplementary services to manage them. The short message service was an innovation brought to mobile phones by GSM. Additionally, GSM technology provided support for circuit switch data calls and telefax. This diagram introduces the architecture of a GSM network to support those services. The GSM phones are called as mobile stations in the GSM specifications. The phones communicate over a GSM radio interface with the GSM base transceiver stations. The base station controller node manages multiple such base stations. Mobile switching centers are the telephone exchanges used to route and connect voice calls from and to the GSM phones. Home location register, together with the authentication center, supports authenticating and tracking the locations of GSM users. These network entities are connected over corresponding network interfaces, shown as the lines between the boxes in the diagram. The different entities of the GSM networks communicate with each other using various tailor-made communications protocols. For each network interface, a layered protocol stack is designed to support all necessary aspects of communications, such as modulation to the physical media, multiplexing of users and channels, data transfer, error detection, and correction. System interactions between the network elements are visualized by this kind of sequence diagrams. The names of the messages shown in the sequence refer to the names of protocols shown on the protocol stack diagram, which we saw on the previous page. In this diagram we can see how the network pages a GSM phone in order to wake it up to receive a circuit switch call. The phone responds to the paging attempt so that a new dedicated voice channel can be established for the incoming call. This diagram depicts the multiplexing structure used on the GSM radio interface. GSM voice channels use frequency hopping, where the used operating frequency is changed for each burst of transmission, roughly in every 4.6 milliseconds. The frequency hopping used together with time division multiplexing allow the GSM base stations to simultaneously support multiple calls for different GSM phones. In the diagram, the vertical axis represents the radio frequencies used in the GSM network and the horizontal axis the time. The gray boxes connected with arrows show the frequency hopping sequence which the GSM phone uses for its voice channel as instructed by the network. At different points of time, the phone tunes itself for either transmitting or receiving a small chunk of voice, or to monitor other cells to support handovers while moving. To learn more about GSM or other systems such as the 5G networks, please refer to the book Converged Communications, Evolution from Telephony to 5G Mobile Internet.